Masterverse, we chase the light. Cohort Season 7 rise. On the blockchain we are wise. Innovation in our eyes.
Give me a thumbs up if you are totally new to ZK, you have no idea what this is, and, like in general are starting from ground zero. It looks like we have a few in the audience. What about like super pro? You think that like you use zero knowledge proofs, like you know how to write circuits and all this, like Halo 2 or CirCom, like that's your thing. Anybody here like that? Yeah. What does CK mean? Indeed. ZK, it means zero knowledge, and it's referring to zero knowledge cryptography specifically. So, for those who are totally new, for your sake, let's talk about just the basics real quick. The idea there is that I want to prove to you that I know something that I won't reveal to you. How do I go about doing this? And in the context of a mathematical, rigorous way, this is where zero knowledge with a capital ZK, like actually the cryptographers would define it as a thing. You're able to do this with some fancy math that I can basically describe what I would like to prove to you with a set of constraints and prove to you that I fulfilled those constraints mathematically, even though I haven't revealed the actual thing. And those constraints are usually around an equation. So you hear about, like, maybe you've heard this term arithmetic circuits before. This is a lofty way to describe, like, instead of using literal, circuits that we use on a computer, composing gates of various kinds. You talk about addition and multiplication as part of your circuit. So you're like defining a whole set of addition and multiplications that defines a circuit in your program. So you get into this weird headspace of describing, trying to prove something to somebody in terms of equations. And like, if you want to prove somebody to like something very simple and mathematical, maybe this is an okay way to go. But if you want to prove something that's more abstract, this gets significantly mindfucky very quick. It's like, how do I describe like that I had a valid TLS session with some dude and like there was data in it in this particular way in math? Like describe that in a polynomial, please. Weird. That's hard. So I think what we're seeing emerge now, and this is what I can talk to us more concretely about, is the zero knowledge used to prove not just a piece of data, but to prove an execution trace. So I don't know if you guys are familiar, maybe some thumbs up or whatever in the crowd. Execution traces from general computing, like basic computer science. Maybe thumbs up, somebody. Anyway, I see Deacon Bro knows some of this stuff. Lilith, maybe. Cool. So for those who don't, essentially at the base level, like we're talking way down deep in the CPU, you have different instruction sets. So you've got the Intel x86 that pretty much everybody's using nowadays, or if you're on a fancy new MacBook, it might be one of the ARM instruction sets. It's targeting their specific custom Mac Apple Silicon stuff, right? But those have been the two dominant players for a long time. Reduced instruction set and then complex instruction set, which was Intel and versus kind of AMD and whatever licensed stuff they did. Now there's this new player on the scene, RISC-V, which is a new instruction set. So it's like, how can you describe the last layer interface between the computer and the hardware, right? So these are the instructions you're literally passing to the CPU. So all that said, right, this instruction set, or excuse me, this execution trace is defining all of the memory registers and the operations that a CPU would take clock tick to clock tick, right? So we're literally looking at like a virtualized register machine. And this is proven that each one of those steps that you took in this clock was valid, right? So in there, what you amount to is instead of thinking about proving all of the transitions and things as math, we've done that job for you with zero knowledge virtual machines. And you just need to write a program that can execute for a RISC-V compatible machine. So I know there's a lot of jargon that I said in those, like that expose. But what I want to convince you of, like the point is, today you don't have to write fancy moon math. You don't have to even understand it. What you do need to understand is concretely, how do you want to define a program that can be run by somebody who is potentially hostile and know for sure that you have the same kind of trust guarantees as if you ran it on your own trusted RISC-V hardware, like locally. This is what we're providing as a mechanism. So verifiable computation is the real primitive here. Does that all kind of make sense? Questions, blank stares, floating heads. Um, so in general, why this I think is pretty wildly captivating is if I can verify execution happened, not just like a piece of information out there in the world, now I could use that to like convince a party that otherwise didn't do the execution that it was done correctly, and the result that came out of the execution is something I should trust, as if I ran it myself. So captivating idea is what if you're trying to convince a blockchain of something, right? You can convince a blockchain like, no, you didn't like go through all of the checks that yes, they are on the whitelist and yes, like they have some weight of tokens that can subscribe to their vote, but somebody tallied those votes and here's the results. And we know that only the right people could have voted in this election, right? That's pretty captivating. So now we just need to update the state, like, yes, the proposal for our DAO passed, and all that gas that you would have spent doing the actual tally on chain can happen elsewhere. So you've convinced a blockchain of, yes, indeed, that logic couldn't have been faked, and someone did this whole thing correctly end to end.
Yeah, it's good to hear some of some of the actual use cases that people
Yeah.
can like wrap their head around. We got a couple questions. One is like, we got Risk 5 for the win, and then how to write ZK in a normal programming language, like versus Rust, or
And Rust is
is that
becoming more
normal?
normal. It is still kind of weird. So maybe one of the most captivating, knowing you guys, will be our governor example. So I'll pull that up and I'll share a link. Where's the right place to put this in the chat for this call,
Yeah,
chance?
we're on the right.
Okay. Um, sorry, I should be better at Discord. Here we go. So we have a Foundry template that you can start poking around. And if you guys are familiar at all with Foundry, this is like a Rust-based library and toolkit to interact with EVM networks. And that also is based on some libraries that we built out, some of which are pretty captivating. I can get into more details of, but there's a governor example where the Open Zeppelin governor contract, we take all of the execution that would have gone on chain and put that off chain and improve the result. And the crazy part about that is the gas saved is like an order of magnitude in terms of cost in every case. So, and it amortizes. The more you do this, the more it pays back. So if you want to have a DAO with hundreds or thousands of members, it's a no-brainer to bring all that tallying and stuff off chain and just submit the provable result, in fact, verify it on chain to update or pass the proposal.
So this is an example of like off-chain and on-chain. The off-chain compute obviously is much cheaper, but um, but we've always had the problem of being able to verify that, and so this is really what we're like, why we're so excited about this kind of stuff.
Precisely. Now it produces this mathematical object called a snark, right? It's what we use as a Groth 16 snark. And this is the cheapest thing that we have thus far on Ethereum to be able to like do those math checks that you don't have to worry about. Like under the hood, our cryptographers have made all that logic. And you just write normal Risk programs, or excuse me, Risk 5 compilable programs. It turns out that Rust is a really good tool chain to build optimal and very heavily optimized code for Risk 5 above a lot of the other options that are out there. So we have some examples of doing things like Python, running it inside of our ZKVM or JavaScript, but because those are interpreted languages, right? It's hilariously expensive computationally to do all of that overhead instead of a very concrete optimized binary from this LLVM thing. So it's you can do other stuff. It's just not very practical today. I think you give it another like 6 months or a year, we're seeing like an exponential. I think we're still on the exponential up curve of performance gains. In a lot of tricks that were yet we know that we can do these tricks, we just haven't implemented them yet to make things significantly faster. So many orders of magnitude in terms of performance, I would expect in the next few years.
Another question here is like, can you explain the architecture of off-chain v on-chain? I think this comes up
Sure.
a lot, right? Because it's kind of like, oh, but even if it's off-chain and we can verify it, we still have like, we're adopting platform risk. So So yeah, what is the state of that?
So y'all see on my screen.
Oh yeah, let me hop over.
Is this coming up? Good. Yes. No. I need a verbal confirmation because I can't see it anymore.
Oh yeah,
Sorry,
yeah.
Yep.
friends.
I can
It's
see
good.
it.
Okay. So we can do this little fusion dance. I don't know if you guys like Dragon Ball Z, but to give you a sense of your question, so I've talked about some of the stuff without the slides, and this was specifically for a hackathon. We can get into the internals of how the risk zero logic works, but really, to answer your question, this is kind of how the whole flow looks. So we've got this like I like to call this like the orchestration application. It's some service that will run and compose like, hey, this is the program that I want you to run to be verified. And in this case, you're shipping it off to a proving service, Bonsai. This is our centralized prover that has a bunch of GPUs that we spin up for you. It's free right now. So if you guys want to play around with making real proofs, hit me up after. We can get you an API key. And then that returns this proof that's generated of your execution back to you. And then it's up to you to take this and ship off a transaction that includes this proof object to whatever your app specific contract is. And within there, you're going to import the risk zero verifier contract that we have deployed on a few different. So you call out to this verifier to like take this receipt object, which includes this cryptographic seal, and checks it. So basically, it amounts to like an assert statement in your contract. So for example, here, if we look at the contracts for the governor, right, we have this baseline governor. I believe the risk zero governor. Is this the one? Where we're having this verifier contract. Are you able to see this is too small? Somebody let me know.
You could zoom
Maybe
in a little. Yeah, that's good.
Okay. So we have this various boilerplate, but this is the important bit, is we're bringing in this verifier, right? And then if we look for that, right, we're grabbing this verifier and shoving it into constructor. And I think eventually this should be the verifier here. Yeah, it's passed around a little bit for this constructor, but I'm looking for where it's actually called. I think it should verify is the key. Verify and finalize votes. Yes. So we have this verifier contract that we ship off a cryptographic seal, and this image ID actually commits you to this specific program that you ran, because you can run any program, but we got to tell you which program would actually pass as valid. So you pass it basically a hash of the program itself, as well as this journal, which is like the output of the program, and specifically the hash of it. So here it's like Magic Moon Math, the program you ran, and the output of that program. Let's make sure that all those combined actually verify. If this assert statement fails, it'll revert. The whole thing fails. But if it does pass, then we can actually go ahead and finalize the votes and just update based on whatever the output of the program was, which includes like what the proposal was settled at.
So in this case, is all the voting happening off chain as well?
Yes. So in here, this is kind of complicated for stupid reasons I can get into if you're interested. It's buried down in here. This is the actual proven program, right? So in here we import, I don't know if you guys know some Rust, like we're using some various libraries. It's cool because the RISC-V virtual machine, it's compliant with almost all of the crates. So we do like, I think it's report dot risk zero. Sorry, as an aside. Pretty sure this is it. Yeah, you can look at this crates.io validation. This is the top 1,000 crates that we test every night. See if they work out of the box, just like compiling inside of this proven program. And the ones that don't compile, like this HTTP one, it doesn't compile because it can't connect with the outside world. You're in this little sandboxed universe that you can prove. Everything that happens outside of the little sandboxed virtual machine, we have no idea of the validity of. We can't prove that mathematically. So you don't have network, you don't have I/O out of the box. You can emulate it, and I can show you how we can do that later. But quick aside to let you know, if you're going to use this stuff, almost all the crates work minus those two caveats. You're sandboxed.
So
And then we need, sorry?
to go back to the governance example,
Yeah.
what I'm trying to think through is, so someone makes a proposal that's linking
Mm-hmm.
to the thing you were showing there.
Mm-hmm.
What I'm wondering was like, if are we passing in parameters through that? Like, how how do we do the like basic require kind of statements in Solidity to check
Basic.
that someone has tokens, for example? If we have no network and no I/O.
Ah, this is also a good question. So, if we go back here into specifically this is the proven program. Um, so in here, I don't believe we do the step that you're asking for, right? We feed it in, I believe, unverified input proposal stuff. So you say, here's the proposal. Um, we take these votes, and this is passed into the environment, I believe. And forgive me because I haven't looked through the details of the innards of this recently because it's been updated. Um, but so in here, we're taking wherever we source this information, potentially unverified right now, we can do all of the tallying logic with some basic match statements like, what did you vote, right? Were you signed? Were you not? Now we figure out like if you should be in this and otherwise kick you out of the voting set. But I think what you're alluding to is how do I verify on-chain execution on-chain is like something here, right? So like if you're reasoning about, do we talk about this in this one? Like, how do I know? Yeah. Now let's go to somewhere else. No. We have this library, Steel. And so what Steel does is it wraps Alloy, and Alloy is an basically a Rust-based library for doing RPC interactions with an EVM chain. So in general, you can do all kinds of fancy things. Basically, provable interaction with an RPC node. So you can do like a an example in here, I think, is a balance lookup. So like this um, this here, this ERC20 example, will have you have the ability via Alchemy, right? You pick this Alchemy endpoint, which you don't have to trust, by the way. And then in this guest code, you're able to basically pass what looks like a contract call. So this is from inside the proven environment. And this contract call builder does a call, but it's an abstraction from what the host actually does this call, right? So we build this like pre-fight, and this is in the external environment that's actually operating your proven code. We call it the host, and we call it the guest that's inside. So guest is this proven special logic that you're actually able to make this proof about, and the host code is just the operator of that virtual machine. So what we end up doing is defining a contract call, actually performing that to the endpoint out that in RPC world, and then passing that into the guest code. So this ENV environment is actually something that we shove into the provable area here in our program.
Okay.
So this is abstracted. These calls link together because effectively it's like a pass through. So we get the emulation of a network call via this.
Okay. Yeah, that's very cool. Very juicy. People are going to be using it.
Yeah, so I think I'm convinced that relatively soon, just because we're looking at this governor example, um, that the all on-chain execution is going to go off-chain relatively soon because of this, right? Is because the general gas costs are on-chain in blue and off-chain in orange here. They're so significantly less, and the performances of our systems are making the cost to do this. So this is just gas cost. It's not factoring in the compute cost. But the compute cost is rapidly declining, so that in every case, it will be cheaper to do off-chain execution, which is kind of nuts. So we don't have the tooling yet, but at some point, it could be that you take your normal audited Solidity code, do some weird transpilation thing, and now you have the essentially what we've done manually here in the contracts is like baseline governor versus the risk zero governor. We can transform that for you. And now all your execution happens off chain, and you pay some decentralized proving service, the whatever fee it is, it's substantially less than gas to do the same thing that you were always doing already. So That's what I see as like a captivating use case for what we're building on the back end now, which is that decentralized proving surface. Um, and
That might go in.
hopefully,
We had
yeah,
a depend talk earlier, and
yeah,
so that could be another situation where depend is making sense, having some kind of distributed network of these services.
yeah, yeah, I could see that. Honestly, I think right now it's going to be the purview of those who have multiple GPUs to orchestrate. But in a year or two, I bet you that it's going to be like your little laptop at home sitting around is going to be fine, and maybe even mobile phones. Oracast is one of the people who's been like poking at us. We're not ready for them yet, but these guys do like all your old mobile phones. They strap it in, so you have like potentially thousands of edge small nodes on the network, like that kind of thing. Could be cool to see. Not today, but
For a real world use case, someone was talking about like healthcare and like disrupting that industry. Do you think
huh.
ZK has a place in that?
Yeah, I think one of the most captivating use cases that I've been kind of getting my head around is privacy. So we've talked all so far about like scaling blockchains, right? Um, and I don't think that medicine, at least today, cares at all about blockchains. Like maybe eventually, but they do care about privacy and selective disclosure. So what zero knowledge proofs can do, and specifically with the ZKVMs, right? It's pretty easy. I have this interface between the host and guest, and I can shove information into it, and I must explicitly commit anything that I want to bring out of the box into the outside world in a provable way. That's this journal object that you can read information out of. So like it's pretty easy to like and pretty easy to conceptualize, but as a product, I haven't seen it manifest yet. I have a local self-sovereign enclave of my personal data, whatever it might be. Most notionally, it'd be health data. Now I want to prove to somebody, let's say it's an insurer, right? Hey, Mr. Insurer, I don't want you to know like if I smoke or like what my mental health status is, or even if I'm a guy. Like but I will run your algorithm that I know is vetted by other professionals not to just exfiltrate my private information because you could make a program to do that. Um, but I'll run that against my health data and produce this result that's like a risk score. Be like, okay, I can prove to you that I didn't just make up bullshit. Like I ran exactly your analysis locally. I won't tell you my data, but I will tell you the result of your analysis. That seems pretty hyper captivating to me for medical field and in the context of insurance, and really in any way. But it does unfortunately have this problem that like the infrastructure to have self-sovereign data that's attested to and trusted, like to not be edited by me, and that whole side of the world isn't made yet. So we can make these cool things happen, but we need the infrastructural side to get better first.
Thank you. Yeah, this is really interesting. Was there anything else you wanted to? Does anyone have any questions? First of all, and one question was how do
I,
they? Oh no, go ahead.
sorry, I have a question. Like,
Mhm.
I started looking into Rust and I found that they have Rust links, which is incredibly helpful for me to just get my feet wet. And I tried looking into the ZK stuff before, but it was like an unsurmountable wall of just knowledge that I didn't have in my head yet. Is there something like Rust links but for ZK stuff? What would you recommend to start off?
I think Rustlings is actually your answer, at least if you want to use a Rust-based ZKVM. Because in the end, the programs that you're proving are actually, because they're so expensive to prove, relatively speaking, computationally, and you can't do fancy like async await. It's a single threaded environment. It the it's pretty basic Rust, and we're proving that, right? So the extra cognitive overhead that we've kind of been discussing today about this like host and guest environment and how do you plug these things together, cognitively it's complex, but in actuality, like the code that's in place is actually relatively simple. And so if you get pretty comfortable with some of the basics of Rust, like if you can read through the Rust book and finish this like multi-threaded web server, you're well more than capable of at least reading through some of this guest program stuff and kind of getting some of the gist of how it works. Um, Beyond that, though, I agree with you. I wish there was an easier on-ramp. And we've thought about it. For now, I think it's going to be a standing problem, at least on our end. I will tell you a little plug for our direct competitor. There's various reasons why we don't like them. Well, they're a direct competitor. But Succinct does have some really interesting onboarding stuff that's available. Succinct makes a product called SP1. They are almost identical in terms of the front end. This like idea of a host and guest and writing code for that's proven and ultimately commit stuff out to the world in a journal. It's because they're using our code for that. So they might have better materials to like help get you started and walk you through. And in the end, what we're seeing is that our complexity is a little bit higher, but it affords more hooks and like ability to make programs that are more performant. So I think it's worth checking out. Like if you're, I don't have a good lay of the land on other ZK VMs, but I will leave you with this. ZK Hack is probably my favorite community in the whole world. These guys do the ZK podcast. I don't know if anybody listens to that. If you don't, it's one of my favorite ever podcasts for a variety of reasons. But it's not just ZK. It's like advanced cryptography. I know we were talking about like maybe FHE, and I'm down to stick around a little bit longer for those who want to talk about FHE, but I know that some might have to run, so don't feel stuck here. Advanced cryptography, programmable cryptography, I find wildly exciting, and ask any question you want in that ZK Hack dev community. And it's not just me who'll be there, there's others. And if you want to ask specifics about Risk Zero, then come find me. We got a Discord too.
Cool. Thank you so much.
Yeah.
So I have a question. So with what you have right now, can you basically run an arbitrary Solidity contract through it without much of a dev overhead?
Not yet. I'd love for that to be the future of where this is, but you'll see in this example, I'll link this again. The governance example specifically, there's some custom contracts, so you can look at the baseline versus our contract for this, and you'll need to manually make those changes. Essentially, it's just ripping out all of the on-chain execution bits and plopping that into Rust code. So today it's a rewrite of Solidity into Rust to do the same kind of operations. So it's not as clean as I'd like it to be, but hopefully someday that it really will be. You can just execute Solidity inside of it. There are projects like Reth. I don't know if you guys have heard of this. This is the Rust Ethereum client. And we have a Zeth client. So this is effectively ZK-ified Ethereum. So if you want to raw dog it and run binary, or run EVM bytecode inside of this using this provable environment, that's definitely possible. But the linkage back to getting it on chain isn't really an easy story right now, at least as easy as this template. So the answer is probably we could do that, but it's going to take some work to get there.
I gather from what you say that there is the overhead of rewriting the logic, but basically you can do anything that you do on chain.
Yes. In fact, you can do far more than you can do on chain. So we're calling this product boundless to try and really get home this idea of unlimited execution. So right now you hit a gas limit at some point, right? In an off-chain environment, we have no gas limit. You can do as much computation as you want, potentially an unlimited, unending program that you can prove in chunks over time and basically have an everlasting like loop that you're just continuously proving the state of. That kind of thing is possible. So in that, you can do things that are impossible on in fact, you can write Rust, anything you could do in Rust land. Solidity is kind of a confining language. And maybe this is a question for the Solidity devs in the audience. One thing that I can do is use the Steel library to call and do view calls, but I could also look at private state, right, of contracts. So in this, I can reason about private state that I couldn't in contracts before. So I don't know if anybody can think off the top of their head, like if I could effectively erode the private contract boundary in some contract call, because essentially this is what it allows you to do. Would that be useful in some way?
my guess would be some attack vectors open.
Maybe. I think though it's
it'd
kind
be
of
useful. I mean, maybe there is a way if you got into the assembly
yeah.
to read the private.
Yeah. Basically, you're not confined to the EVM anymore. So you can do anything that a normal programming environment could do. So it's whatever you'd like to prove to the EVM and plug that into a contract and like with a verify statement, you can do. So the world's your oyster. It doesn't have to be just what Solidity can express. The other thing that's
would it
cool. Oh, sorry. One last idea that I'll throw at you guys is this idea of Steel can do lookups like RPC calls for historical blocks. So now one captivating use case would be like Uniswap v4 hooks, right? So I could make a hook that says I want to query this last like period of time for this account's interactions, and it's like basically a volume discount. So I'd be like, how many times did you trade on this pool? And based on that, your fee rate should be X, right? And from there, like you can do some magical things that would be impossible because the EVM only reasons about the state as it is in this block, right? So composing with basically a time dimension that wasn't possible before is kind of a cool idea. Oh, cool. It's perfect. Mine's thinking alike, Yellow. I like the Dragon Ball Z references are pretty great, guys. We got to do more of those.
One other question: Do you know what bonsai is?
Yeah, so Bonsai is our proving service that's a centralized service that we run. It's free to use as long as you ask nicely. I'm the guy who ultimately doles out most of the keys. So here you can run these proofs locally, but anything that's interesting, like running one of these steel proofs, is probably going to take minutes or hours. And if you're running a MacBook with some of the fancy M chips, unfortunately, there's a last step where we take basically convert one proof that's rather large to this Graph 16 proof, and that has some hard coded like x86 instructions that. So it just totally fails. Docker doesn't help you. Nothing helps you. You can't use it on Mac chips right now. So if you want to do real proofs, you can use Bonsai to do this, and they'll always work. And generally, get done as fast as we could possibly muster with our system today. So that's possible. I'll leave you with a note though. If you do start playing with this, absolutely positively don't make real proofs. Do execution only. So this is using the RISC-0 dev mode. And because we're proving correct execution, if you can prove in your tests and stuff in your demos that the execution worked correctly, you trust your own machine. You only need the proofs when you're running on untrusted hardware or you're trying to convince Ethereum mainnet of something, right? But to convince yourself, just run the execution and you should trust it.
Someone earlier said that they started getting more wrinkles in their brain when thinking about ZK stuff. And, I'm definitely feeling that now. Does I think the other question was we wanted to just like a super quick because it's running up against the end of the time now, and I think that's very late. But super quick on FHE.
Yeah. So what we've been describing to give context, ZK allows me to have private information and prove to you something about it, right? Whereas FHE says, I have some private information that I'm going to encrypt and give to you, and I want you to operate on it and then give it back to me encrypted, like the result of whatever I asked you to do. And all along the way, the remote party is the one doing this hard work to try and preserve privacy. In fact, should have really no understanding of what they're doing. So it's zero knowledge, so to speak, on the other end. Whoever's doing zero knowledge proofs has penultimate knowledge. Like there's some asterisks, there's tricks you can play to make things private on the prover side. But ultimately, the prover is trying to prove to the world stuff that they know. Whereas in FHE, it's like, hey, I want somebody else to run a program, but on data that they have no idea what it is, right? And potentially both the data and the program itself could be totally encrypted. So it's like run this like totally obscure thing that you have no idea what you're actually running on this weird random encrypted ciphertext, and like return me some different ciphertext, please. And I'm the only one who'd be able to suss it out. So in there, you can do some pretty captivating things about privacy preserving, like cloud computing in general, and potentially some interesting things around multi-party computation. There's a lot of like overlap that like FHE and MPC, depending on who you talk to, maybe the same thing. They're at least manifest as the same thing, even though they're definitely not the same thing when you talk to the cryptographers. But that's my TL didn't DR of like what FHE is. I would suggest, and I'll bring it back up. I posted a link. If you want to get your mind rocked by a blog about all these cool use cases that might come about from various new advanced cryptography, programmable cryptography, OXPark is a great one. I check that one out. I'm still getting my mind exploded every time. I've read it like 5 times. It's good.
Great. Thank you, man. This has been super awesome, and people have been talking about it all week. So, thank you for coming.
Hey.
Tay, did you have
Hell
anything
yeah.
you wanted to ask?
Was that me? Oh yeah, Tay. Anything?
No, I don't. Maybe Dan, if you'd be willing to come back, and then we can maybe do like a deeper dive. We lost a lot of folks. We had some a lot of folks on earlier, and then if there's any topics that we can go deeper into, or even if there was like a jam session, we try to build something really small and easy. That'd be kind of fun too. But just throwing out some suggestions.
Also,
Absolutely.
someone was asking if there's any alpha on which coins to buy.
I honestly, I don't pay attention to the markets, guys. I'm sorry. And when it comes to ZK coins, I don't know. Like the tech is pretty new. Like something. I didn't say it, but like we're probably doing a token maybe with this boundless thing. I have no idea when or how that will manifest. Right now, we just brought on some general counsel people to like figure out if our ideas are even legal, like in the jurisdictions we want them to be. So TBD, but will see a lot of like blossoming interest in various verifier networks, aggregation layer stuff. So if you look for some of these keywords, you might start finding tokens around.
Amazing. Thank you. Oh, and I guess if you can share your deck, that would be awesome. And
Sure, yeah, I'll post in the chat. I've got a book, MD book, which is a thing that comes from the whole Rust land. Let me see. I lost my chat. 1 sec. Here we go. So if you want to go look at the source file, there should be a link to the website itself that's rendered if you want to check it out. Got other slides and workshops. So I would encourage, I'd say the chess workshop is probably the best example of this. Let me link to that real quick. If you wanted just like a quick and dirty introduction, this one I actually recorded some video, but it's kind of stale. So I wouldn't actually follow the instructions in using an old version. But if you wanted to like kind of get a flavor of what it's like to build one of these things, that's probably the best place to start.
that's great. Someone in the intro was actually saying they wanted to do a ZK chess thing, so this is...
Yo, check the mic 1, 2. Squeak, it's Hammy G. Descending into the abyss where things get funky. See, this ain't no Disney flick, no cheesy cartoon chase. This Moloch's lair, a bureaucratic soul-crushing space like Dante's Inferno, with more paperwork and fees and demonic interrupts and